Okay, class, picking up where we left off at, we replaced positive 4t and minus 10t for the negative 6t. So we grouped the first two values. 5t squared and 4t only has t in common. So that would leave us 5t plus 4 in parentheses. Now we look at the second two values here. We had negative 10t minus 8. Since this first value is negative, whatever we factor out must be negative. So they only have 2 in common, so it'll be a negative 2. And that will leave us 5t plus 4. Now, we will write one parenthesis with everything on the outside, which would be t minus 2. And then one of the two repeating parentheses, which is 5t plus 4. And that is the final answer. Okay, now we move on to D. D, we look here to see if we can factor out anything. If you look here, we have, if you look here, we cannot factor out a number, but we can factor out a variable. The only thing we can factor out here is an A, because A is in all three terms. So that would leave us 3a squared minus 10ab plus 8b squared. Now, this problem is a little different than the other problems we encountered because we're dealing with two variables here instead of one, but we still do it the same way. Now that we isolated the greatest common factor from these three terms, we'll go off to the side and list our A, B, and C. Our A is 3, our B is negative 10, and our C is 8. Does everyone follow that so far?
So that's already in descending order.
Yeah, because, okay, they are in descending order because when you have multiple variables and you have singular variables, you go alphabetical order. So A comes before B, and then AB comes before B as well. So that's why the A squared, then AB, and then B squared. Okay, so now we multiply our A times C. Now we know A times C here would give us a positive 24, because that would be 3 times 8. Now, let's take all of the factors of 24. We would have 1 and 24, 2 and 12. We would have 3 and 8, and also 4 and 6. Now, let me ask you all a question. Look at B here. You notice that B is negative. How can we get a positive answer, but add it together give us a negative answer? You say what?
2 negatives.
2 negatives. So we would make all of these negative. So, now we have to add these together. And whichever one gives us negative 10, we will use those two values. We can see here that negative 4 and negative 6 will give us negative 10. We don't have to add all of those together. So now, this is what I want to do. I'm going to leave this A off until the end of the problem. What I'm going to do here is I'm going to deal strictly with the parenthesis for right now. So this would be 3a squared minus 4ab minus 6ab plus 8b squared. Because remember, this minus 4ab and minus 6ab replaces the negative 10ab. Now we group these first two terms here. The only thing they have in common is a. So this will leave us 3a minus 4b. Now we group the second two terms here. Negative 6ab and positive 8b squared, they both have a negative 2b as their greatest common factor. So this will leave us 3a minus 4b in parentheses. So if you notice, the two parentheses are the same. So everything on the outside will go in one parenthesis. And then we will write one of the two repeaters. But don't forget that original A we had.
So does it go A squared now?
No, this is it right here.
Okay.
The A would just go out front. and we're done. This would be a totally factor. Any questions? All right. We'll scroll on to the next page. We have sum of cubes pattern and then a difference of cubes pattern. Basically, if you look here with the sum of cubes, you have a plus b, then a squared minus ab plus b squared. Now, what I want to do is this here. I want to go through and do a problem. I think that's a lot more effective than talking about these general formulas for you to actually see it and see it actually done. Now, here we have the difference of two squares. We know with the difference of two squares, we have two parentheses. One to have an addition sign, one to have a subtraction sign. We would take the square root of x squared, which is x. So x would go in both parentheses. Square root of 9 is 3. 3 would go into both parentheses, and you're done. That's the difference of two squares. Now we go here. Matter of fact, yes, with this problem here, 12x cubed minus 75x. We need to see if we can factor anything out before we do anything. 12 and 75 both has 3 in common, and x cubed and x has x in common. So this will leave us 4x squared minus 25. Now 4x squared minus 25, this is still the difference of two squares. So we would do our two parentheses and of course bring down our 3x. We have a plus in one and a minus in the other. The square root of 4x squared is 2x. And the square root of 25 is 5. And there's nothing more we can do with that. Okay, now, we scroll up a little bit. We go here to C. 49 minus w squared. Even though it's technically out of order, this is still the difference of two squares. So you'll do your parentheses, plus in one, minus in the other. You can put the minus first or the plus second, it doesn't matter. So now, square root of 49 is 7. Square root of w squared is w. So this is your final answer. Now, we have the addition of two cubes. We have x cubed and 8. Now, everyone knows that 8 is a perfect cube, correct? And the reason why it's a perfect cube is because we know 2 times 2 times 2 will give you 8. Okay, so now, we need to do the pattern for the addition of two cubes. So this is what happens. You have one parenthesis that will hold 2 terms, and then one parenthesis that will hold 3 terms. In that first parenthesis, you would take the cube root of both of these terms. The cube root of x cubed is x, and the cube root of 8 is 2. And it's addition. Any questions on the first parenthesis? Okay. Nothing like a live recording. All right, so we go to D. Okay, now, to get the first term of D, whatever the first term is in this parenthesis, you square it. So since this is x, this will become x squared. Now, to get the second term, you will multiply these two terms and take their opposite. 2 times x is 2x, right? So it'll be a negative 2x. So let's recap the first two terms. The first term, you will square this term. That'll be the first term here. To get the second term here, you will multiply these two terms and take their opposite, which would be a negative 2x. Now to get the last term, what you would do with the last term is you would square this last term. 2 squared is a positive 4. And that is your final answer. Any questions on D?
Well, why wouldn't we simplify it further?
You can't simplify this.
You can't?
Yeah, because if you list your A, B, and C, A times C would be 4, and we already determined that you only get like 2 values for 4 when one of them is negative. It'll be either 0 or 3, or negative 3. Okay. So we would never get the negative 2. All right, let's look down here at E. Now the first thing we do is look for the greatest common factor to see what we can factor out. We can factor out a 2. Then we will be left with x cubed minus, oh, it's supposed to be 27. X cubed minus 27. Now, x cubed is a perfect cube, and 27 is a perfect cube because 3 times 3 times 3 is 27. Now, one thing you could do to figure out if a number is a perfect cube, you could take your calculator and put the number without the sign under a cube root and see if it gives you a singular number answer. And that would tell you if it's a cube root. Okay, so now, well, actually, you could put the sign in too. So now we have to do the difference of 2 cubes. So we'll bring down our 2. We will have one parenthesis that would take 2 terms, and the last parenthesis that would take 3. So now with this first parenthesis, the cube root of x cubed is x, and the cube root of negative 27 will give you minus 3. Does everyone follow that so far? Okay, now, just like in the last problem we did, the first term in this other parenthesis that takes 3 terms, you have to square the first term here, and that will become the first term here. Now to get the second term, you multiply these 2 terms and take their opposite. Negative 3 times x is a negative 3x, and its opposite will be a positive 3x. And then the last term, you square this negative 3. Negative 3 squared will give you a positive 9. And there's nothing else we could do with this. So we're done with E. Now we go to F. 27p cubed plus 64q to the third power. Let me see, 27 and 64, they have nothing in common. And p cubed and q cubed has nothing in common. So 27 is a perfect cube, and 64 is a perfect cube because 4 times 4 times 4. So we have the addition of 2 cubes. So the cube root of 27p cubed will give us 3p. The cube root of 64 cubed to the third power will give us a positive 4q. Now, we have to square the 3p, which will give us 9p squared to give us our first term here. We have to multiply the 3p and the 4q, which will give us 12p cubed, but we'll take its opposite, which will be a negative 12pq. And then finally, we will square this last term here. 4 squared is 16, and q squared is just q squared. And there's nothing more we could do with this problem. All right, so